Hello everyone, we are still in week 1 of the first quarter of this school year and we are going to study lesson 1.4. Let's discover the pattern of a sequence. For lesson 1.4, we will look at specific sequences. These are linear and quadratic. At the end of this session, you will be able to determine whether the given sequence is linear, quadratic, or neither, and write the formula for the end term of a given linear or quadratic sequence. Then calculate the specific term of a given linear or quadratic sequence. The sequence 5, 8, 11, 14, and so on is an example of a linear sequence. In a linear sequence, the numbers increase or decrease by the same amount every time, just like a times table. For this instance, the common difference is positive 3. Therefore, the explicit formula is a sub n is equal to 3n plus 2, where n is the position of the term. This is sometimes called an arithmetic sequence. Example, 5, 7, 9, 11, and so on. To get the end term formula or the explicit formula for the sequence, what times table is hidden in the sequence? When we say times table, a number that we can multiply to the position of the term. Observe that the common difference can be used as our times table. So therefore, we will multiply 2 to the position. So 2 times 1 to get a new term 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 4 is 8. This sequence 2, 4, 6, 8 was formed when we have the times table 2 times n. But this sequence has a different terms compared to our original sequence. Therefore, we have to look at something that we can add or subtract to make the sequences match. For this one, the difference between the terms 5 and 2 is 3, which is actually the same with 7 and 4, 9 and 6, 11 and 8. Therefore, from 2 times n, we have to add 3 to get the original sequence. Therefore, our a sub n is equal to 2n plus 3. To check your work, you can use or look for a specific term. For this example, I'll choose to find a sub 4. In the original sequence, it's 11. So I need to get 11 using this formula. This time, my n is equal to 4. So 2 times 4 plus 3 is indeed 11. Therefore, this explicit formula is correct. Example number 2, 6, 10, 14, 18, and so on. We will do the same thing. What times table is hidden in the sequence? The times table is actually the constant difference between two consecutive terms. So let's see if there is a constant difference between terms. Yes, there is, and that is positive 4. Therefore, we will multiply this constant to the position. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. Our sequence when we have the 4 times n is 4, 8, 12, 16. But we need to get this original sequence from this sequence. So what do we need to add or subtract to make the sequences match? Correct. We simply need to add 2. Therefore, our a sub n is equal to 4n plus 2. You can do the checking by having a sub 3 is equal to 4 times 3 plus 2. That is 14. And this one is 14. So we have the correct explicit formula. Try this. Okay, so positive 3 is the times table that we are going to use. So we have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So our sequence for the 3 times n is 3, 6, 9, 12. To get the original from the 3 times n sequence, we need to add 2. Therefore, our a sub n is equal to 3n plus 2. Checking is left for you to do. Okay, let's have example number 3. 2, 0, negative 2, negative 4, and so on. Again, look for the times table that we can use to solve for this. This time, our times table is negative 2. That means we are having a decreasing sequence. So negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. Negative 2 times 3 is negative 6. Negative 2 times 4 is negative 8. So the sequence for negative 2 times n is negative 2, negative 4, negative 6, negative 8. And comparing the two sequences, we simply need to add 4 to this negative 2 times n to match the new sequence or these two sequences. So our a sub n is equal to negative 2n plus 4. Checking, you can do it. So just by substitution, solving for a sub 4 is equal to negative 4. So we have the correct explicit formula. For example number 4, 2, negative 1, negative 4, negative 7, and so on. What times table is hidden in the sequence? Correct, it's negative 3. Therefore, we have negative 3 times n. And the sequence will be negative 3, negative 6, negative 9, negative 12. And to match the sequences, we have to add 5. Therefore, our explicit formula is negative 3n plus 5. Now you try this. The sequence is 5, 3, 1, negative 1, and so on. Okay, the difference between two consecutive terms is negative 2. That serves as our times table. So negative 2 times n will form negative 2, negative 4, negative 6, and negative 8. Then, we need to add 7 to get the original sequence. Our a sub n is equal to negative 2n plus 7. You can do the checking. Next, the sequence 6, 10, 16, 24, 34. If you will get the difference, you will notice that they don't have the same difference. So this is not a linear sequence. But observe that if we continue getting the difference between these differences, we will get a constant difference of 2. But this time, we were able to find a constant difference in the second layer. This is called the second difference. If there is a second difference, then same second difference, then it is called as quadratic sequence. The steps to get the explicit formula for quadratic sequence is this. First, find the second difference. For this case, it's 2. And half it to find the coefficient of n squared. So 2 times 1/2, or 2 divided by 2, that is 1. So 1 is the coefficient of n squared. Then subtract the quadratic from the original sequence. When we say subtract the quadratic, we are referring to the value of this. And when we say original sequence, this is the original sequence. So place the original sequence here and place the value for the quadratic, 1n squared. So the n here is 1, so 1 squared times 1 is 1. 2 squared times 1 is 4. 3 squared times 1 is 9. 4 squared times 1 is 16. 5 squared times 1 is 25. Then, try to get the difference between 6 and 1. The difference between the original and the quadratic, since we need to subtract the quadratic from the original. Therefore, the difference will be 5, 6, 7, 8, 9. Observe that the 5, 6, 7, 9, 7, 8, 9 forms a linear sequence. So express this part as a linear sequence. How do we do that again? We try to get the difference. Since it's in the first layer, it is indeed linear sequence. And then multiply it to n. So that's 2 times 1. 1 times 1 is 1. And to get that 5, you have to add 4. 1 times 2 is 2, plus 4 is 6. Okay? And so on. And then, join the quadratic with the linear sequence. Link this quadratic to this linear sequence. So that will be a sub n is equal to n squared. We will remove 1 since it is an understood coefficient. N squared plus your linear n plus 4. Okay? Next, we'll try this. 6, 11, 18, 27, and 38. Get the first difference. We are not the same. So therefore, it's not linear. Try to get the second difference. They are equal, and that is 2. Get half of the second difference to make it the coefficient of n squared. So 2 divided by 2 is 1. So you have 1n squared. To form the quadratic, it will give you 1, 4, 9, 16, and 25. Then, subtract the quadratic from the original. It will give you the sequence 5, 7, 9, 11, and 13. Then, observe that the remainder forms a linear sequence. Therefore, it's 2n plus 3. Then combine. A sub n is equal to n squared plus 2n plus 3. Note that to get 2n plus 3 here, try to get the first difference. It is 2. Then 2 times the position for this one. For this term, it's the first position. So 2 times 1 is 2. But your original term is 5. So you have to add 3. Same with this. 1 times 2. 2 times 2 is 4. Plus 3 is 7. And then for this one, it's in the third position. So 2 times 3 is 6. To get 9, you have to add 3. Okay? I hope it's quite clear to you. Next, 3, 4, 7, 12, 19. The first difference are 1, 3, 5, 7, 9. The second difference is 2. Therefore, you get half of the second difference to make it the coefficient of n squared, still 1. Therefore, 1n squared is your quadratic. You form the sequence in that quadratic. You have 1, 4, 9, 16, 25. Then subtract the quadratic from the original. You have 2, 0, negative 2, negative 4, negative 6. And this forms a linear sequence. Since it's a linear sequence, you look for the first difference. And the first difference here is negative 2. So negative 2 times 1 is negative 2. To get 2, you have to add 4 because negative 2 plus 4 is 2. And do the same with the other terms, and it will be verified that this remainder will have a linear sequence formula of negative 2n plus 4. Then join the quadratic and the linear. A sub n is equal to n squared minus 2n plus 4. Next, 6, 13, 24, 39, 58. The first difference are not the same. The second difference is the same. Therefore, it is quadratic. So get half of the second difference. So 4 divided by 2, that is 2. And make it a coefficient of n squared. So your quadratic will have 2 times n squared. Note that when you do this, you square n first before you multiply to 2. So your quadratic will have 2, 8, 18, 32, 50. And then subtract the quadratic from the original. Going to have 4, 5, 6, 7, and 8. This is now a linear sequence. So we need to form a linear sequence formula. The common difference between two consecutive terms is 1. So 1 times the position. So for this case, 1 times 1 is 1. To get 4, you need to add 3. And you check it with the other terms. It is indeed the linear sequence will have n plus 3. Then join the quadratic and the linear. It will be a sub n is equal to 2n squared plus n plus 3. Okay, that would be all for your assignment number 3 this week. We have linear and quadratic sequence. So you have to determine whether the sequence is linear, quadratic, or neither. You have to find the formula for the n term. This one is referring to the explicit formula. Then find the value of the 7th term of every sequence given. Okay? So that would be all for today. Thank you. Stay safe and God bless you all.